Hello, in this tutorial I want to talk about adding boundary conditions to our beam model object that we created in the loading models tutorial. I've got ParaView running, so if I open our model, we should see from the other tutorial we had the original VOX-FE file. We've also got a script file which is the model directly, so we can load that and it will just say re-importing all the images. Script model is detected, so we can just hit apply, and there's our beam model. Looks okay. So the easiest thing to do here, I think, is to choose a line with the Z-axis. We'll make it so that at the sort of Z equals 0 end, or whatever it is, we'll constrain the nodes in that face, and we'll apply a force and a sort of cantilever model at that end. So the easiest thing to do is to use our Z alignment axes. Actually, that takes us to the sort of Z equals 0 end, and we'll switch to surface with edges, so that will show us where our points are. And I want to constrain this face, but I want to do it in a way that is minimally impacting on the model. And the way to do that is to choose one point, let's say the central point here, which can't move, and another point here on the edge which can't move from side to side, and then constrain all the other points in the Z-axis so they can't move in or out of that plane. So I'll start with that middle point. We use our select button, and if I can find the middle point, maybe about there, we make that selection. And as I mentioned before in the previous tutorial, that doesn't automatically create an object that we can actually apply things to. We have to use this extract function to create something in the pipeline. So I click that and apply, and that gives us a kind of one-point object to which we can now add our boundary condition. So I click this Add Displacement or Boundary Condition button, and I choose Nodal Constraint and X, Y and Z. Click Apply. That gives us it actually gives us three triangles in a glyph format. If I click Auto Apply here, we can sort of move those triangles to one side to see what they look like. It is basically those points telling us that point can't move in any axis. One thing we need to do here is to remove that object in the scene, because it is possible to select it again, and we're going to be wanting to choose these points around. So the easiest thing to do is just to decrease the scale. And we can also highlight that just to point out that it's something separate. And now I want to be able to just select around that object, and I think I could just about manage to do that. So if I select all these other points apart from this top middle one, the procedure is slightly different. I want to choose select points. I mean, incidentally, I could use this this sort of hand draw with polygon thing here if I wanted to try and do it all in one, but I don't think that would actually be a lot easier in this case. These other options allow you to click cells and to click right through the object. We definitely don't want to do that. So this is probably as easy really for what we want. I might use the other one at certain times, but these and this one are most useful for our purposes with VOX-FE. So if I choose a first selection up to that middle point there, then I have to click again, and then I have to remember to use Control to add to the previous selection. So there we are, that's added a selection. Click this again, Control, and add, and once more Control and add. So that's selected all these other points apart from this top middle one. It's always a good idea to check around your object. With this particular case, because it's so markedly aligned with the axes, actually it rarely makes this mistake, but you will often choose a couple of extra points on other objects, and it's up to you then whether they have to be removed or not. Note that you can add two existing selections with Control, but you can't take them away. But on the other hand, you can use clip functions to remove those points, as I showed you in another video. Okay, so now if I try to add a boundary condition to those, it will tell me that there's an error because I forgot to click Extract. So if I remember to click Extract, Auto Apply was on, so it ran the apply straight away. I'm going to switch that off for now. So let's add our next boundary condition, and we want to create a nodal constraint which constrains all those nodes in Z. We click Apply and use our highlight just to switch that. So it's actually created another big triangle. It always chooses the middle point of your selection to create the glyph. And it is useful to be able to see what that's doing. So there it is, it's saying you can't move in or out of the plane. So one final point to pick on this face, which is that one, and we then want to extract and apply a boundary condition which will be nodal, and it's in Z, and because side to side is X, we want to fix it in X too. Okay, so that set up this face. Quick highlight just to check. Yeah, I mean the glyphs are very useful to remind you exactly what it is you've set. If I now choose the other -Z alignment and do my right click and drag, basically this is a whole lot easier at this end. We want to choose every node, make sure that it's not overlapping or choosing any extra ones, and then we extract, apply, and add the force parallel boundary condition, which we want to be -y magnitude 10, and not on every node. We want it spread across all the nodes, so it just divides equally across the nodes. Click Apply, and then if I click Highlight, it should switch back. So we've now got a big downwards arrow reminding us what's happened. Okay, so that's good to go. We want to output that now to send to our solver, and the way we do that is with this target button, which is intended to imply sending things for solution. And if we click that, it needs two outputs, so it always chooses this input model. Generally it will always be the first object anyway, so that's usually correct. But then we need to tell it about the boundary conditions as well. So if we use Control click, we can click all those 4 conditions. We click OK and apply, and that's it. And what actually happens there, if I just drop that out the way, is it creates a file called constraints.txt, which lists. So that was our first point. So 111 means that it can't move anywhere at that particular point, and then somewhere down here are those forces that are spread out over all those nodes. So that is good to go as far as the solver is concerned. A couple of things that I should mention. I mean that the boundary conditions are still here. They're still shown in our screen if I click the little eyes. A couple of things. One is that this output script filter, it's a very lightweight filter, because all it does is it outputs this information to file, but you can actually right click that, and by choosing change input you might be tempted to use this to change the conditions, and the thing is that just doesn't work as we would expect. It seems to just add to any existing conditions. I'm afraid it's a bug somewhere that just hasn't been able to fix, partly because I'm not quite sure where it is, but also it's very easy to get around. Basically, we want to delete this object and just create a new one if we want to output a different set of conditions. But that doesn't mean to say that you need to go creating all these points again. You can recreate the object from the start, or rather you can save the state to recreate the object from the start by using ParaView's own function, which is file save data. And if we just create one of these PVSM files, it basically runs through all the steps that you did to create the model as it is so far. So you can just load that file again through load state to remember what all your boundary conditions were that you created. Okay, thank you very much.